It's one of the world's largest dump trucks. Hard at work on the oil sands in Alberta, Canada. It's the Caterpillar 797B. And everything about it is huge. Just check out its stats. Height, more than 7 meters, almost 2 stories tall. Weight when loaded, nearly 600 tons, more than a Boeing 747. And power? Enough to move mountains. It's got a giant dual engine that delivers over 3,500 horsepower. That's twice as powerful as an M1 tank. Creating this monster's a job as big as its payload. To build this more than 3.4 million euro beast, it takes mega factories, including 6 huge facilities across North America. Caterpillar creates the engine in Lafayette, Indiana. Michelin manufactures the 5-ton tires in Lexington, South Carolina. The state-of-the-art cab comes to life in Joliet, Illinois. And the 45-ton dump box assembles in Canada. But to join up the huge frame and most of the components, it takes Caterpillar's mega factory in Decatur, Illinois. And where does this titanic truck all come together? Not here. This behemoth's too big to ship to any customer in one piece. To assemble the 600+ tons of individual parts, it takes 20 non-stop days. And it happens on site where the monster machine gets put to work. Places like Fort McMurray, Canada, near the sprawling Alberta oil sands. And before the build, it all starts in Amite, Louisiana, a mecca for molten metal known as the Amite Foundry and Machine Company, where they cast the phenomenal frame.
In the state of Louisiana, we make gumbo, we also make metal.
The 797B frame is the backbone of the truck, the essential building block that holds the mega machine together and carries its enormous weight. The frame's made up of 9 separate castings. It stretches over 11 meters long and weighs nearly 28,000 kilos.
If the frame was too rigid or wasn't designed to flex, it would result in cracking of the frame, would cause extra maintenance, it would contribute to downtime, and ultimately the customer would not be able to haul the ore that he needs to pay for this truck.
At the Amite Foundry, the crew's making the center casting, the frame piece that supports the truck's huge payload. It begins with molten metal, and this is the star of the show. A 45-ton metal melting oven called an arc furnace. Here's how it works. The crew fills the furnace with scrap metal. Operators lower 3 highly charged electrodes into the chamber. When the electrodes touch metal, they create a scorching 2200-degree electric arc. The heated metal bubbles, then melts. 2.5 noisy hours later, this liquid metal's ready to pour. And that calls for this trained team, the ladle crew. The crew uses a manned crane to guide the empty 9-ton ladle to the waiting furnace. Out pours a fiery river of 1,650-degree metal, hotter than a volcano. The ladle crew also has to tackle some critical chemistry. They add packets of aluminum and silicon. These special elements create deoxidation, a process that drives out harmful oxygen, hydrogen, and nitrogen from the metal. Left alone, these gases can form bubbles or pockets inside the forming metal, bubbles that can weaken the frame. Now the tricky part, guiding the ladle to a parts mold. Inside this mold, there's a cavity in the exact shape of the final frame piece. The crew positions the ladle above the pour entrance, making sure to stay back from the scorching heat. Molten metal fills the cavity in a fiery flash. The steel-filled molds have to cool a full 36 hours. Once cool, the mold comes off. At this point, the casting looks rough, with coarse metal nubs sticking out like a porcupine. To get an even finish, crews cut off the excess steel.
All the excess gets cut off. Okay, this, cut here. That gets cut down low.
Another crew then chips and grinds the casting smooth. The last step's called heat treating. The object is to give this hardened steel more flexibility, allowing it to bounce over rough roads without cracking. The part's metal molecules heat up again for several hours at over 900 degrees. As the molecules cool, they rearrange themselves into strong yet more flexible bonds. Heat treating makes a frame-saving difference.
I'm cooking the grain inside of the casting, making it all come together as one part.
It's sweltering work, but they're metal-pouring pros. Once the Amit foundries finished their 797B frame pieces, they shipped them off for assembly at the Caterpillar factory in Decatur, Illinois. But first, to see the load-carrying might of this whopper dump truck in action, it takes a trip to the oil sands of Alberta, Canada. Here, they don't drill for oil, they dig for it. The oil, called bitumen, is trapped in the sand rather than in oil pockets under the ground. The 797B dump truck's critical to the mining operation. Each day, these extreme machines move nearly 275,000 tons of ore. From the mine site to oil processing plants, where skilled workers use crushing combines, hot water, and engine-powered refiners to separate the oil from the sand. Eventually, this crude oil becomes gasoline, kerosene, and jet fuel.
Okay, we're off to shovel one.
Out here, the oil pits are ground zero. These shovels are towering 20-meter, 1,360-ton digging machines that load up the dump trucks with oil sands. With oil demand at an all-time high, every second counts. Working non-stop, each 797B truck delivers the equivalent of 200 oil barrels per load. But before they can haul huge loads, these monster machines have to be built. Decatur, Illinois, a Caterpillar mega factory. With 28 buildings covering over 140 hectares, it's one of the top mining and construction equipment facilities in the world, and the manufacturing hub of one of the world's largest dump trucks, the 797B. Our dump truck in the makings, 9 steel frame pieces have arrived from outside foundries. They're ready for the next steps, machining and welding. Here in Building D, workers first prep the metal joints for a super smooth weld.
This rear casting section would come in rough from our supplier, and one of the things we do here at Decatur Caterpillar is we'll machine these surfaces. When we assemble or weld the truck, we machine these casting surfaces in order for a very tight control of these joints, providing a very good weld joint.
The steel came out and it milled this top part completely flat. Takes about 5 passes to get it to where it's supposed to be. We try to give the welders the best weld surface all possible, so that way there won't be no cracks or anything in the weld.
The Caterpillar frame pieces join together in 3 main stations. The robotic welding area, where machines fuse the main frame together. The checkout station, where the final weld steps finish up. And the area where it all begins, the tack fixture station. Right now, the initial weld's underway. Randy Shorey and his team are putting each frame into a jig, a huge vise that holds them in place.
We're taking all the parts and making the basic frame of what's going to eventually be the 797 truck.
These parts range in weight from over 200 kilograms to more than 5 tons for a single part. Moving them's a massive job. Randy needs help from a remote-controlled crane. But first, he has to position the chain carefully to pick up each piece. One mistake here could cause a colossal crash.
Yeah, you got to get everything just lined up just right. You got to have your chain centered up. And then when you pick it up, you got to be careful so that it doesn't fall over one way or the other. Well, it's leaning a little bit too far the one way, but it's close enough that I'll be able to set it in the fixture.
To ensure a strong weld, Randy has to line up the pieces perfectly in the jig, with only a tiny gap between the seams.
Well, I've just set this part in. Now we're going to take all these here bars and tighten everything up and get it in position. We'll start welding right down here and bring this up and weld it all the way around here and down over to this other side. One of these here probably takes on average 3 or 4 hours, depending on how fast you weld.
Randy and his team must tackle an impressive 18 welds in total. This giant Caterpillar frame's starting to come together, but the monster welding's not over yet. Before the frame can shoulder the load of a 797B dump truck, it has a date with some super-sized welding machinery that takes this assembly process to high-tech heights. For more than 80 years, Caterpillar's yellow iron has transformed the world. No one on Earth makes more construction vehicles, 200 different types of machinery at work in nearly 200 countries. The Caterpillar success story began at the turn of the 20th century in the California farmlands. Inventors were in a race to replace horse-drawn farm equipment with new steam engine power. The first prototypes were so heavy they sank. But in 1904, an inventor-entrepreneur named Benjamin Holt came up with an ingenious solution: tracks.
Replacing the rear wheels of his machines with sets of tracks. These tracks distributed the weight of the machine more evenly and allowed the machine to actually float across the field.
The revolutionary track design kept the machine moving, no matter what the terrain. A photographer saw one crawling across a field and called it a caterpillar. The name stuck and became a Holt trademark in 1910. Then, in 1925, the Holt organization joined forces with farming manufacturer C.L. Best, and the Caterpillar Tractor Company took off. Today, Caterpillar's massive machines surpass anything its founders could have imagined. Decatur, Illinois, a Caterpillar mega factory. This train team's already hard at work building the support structure of the dump truck. A towering steel frame weighing 27 tons. It's strong, flexible, and built to last over 2 decades. An engineering wonder.
We like to refer to it as the backbone of the machine. That essentially is the component of the truck that's going to carry the reliability. We would change out engines, we change out suspension components, etc. But the frame, for the most part, stays around for the entire life of the truck.
You're going to be hitting ruts, you're going to be hitting essentially very large potholes. So the frame must flex in order to take up the bumps in the road.
So far, Randy Shorey and his crew have fused together the 9 foundry-crafted steel pieces into the precise shape of the frame. It's time for the next stage, robotic welding. This 21-axle robot welder towers 7 meters, one of the largest welding machines on Earth. It takes 9 computers to run this automated Goliath. Here's how it works. 2 robotic heads tackle the frame's seams. A touch sensor calculates each weld seam's exact width and depth. It takes the machine more than 20 long hours to fuse everything together just right. Conquering this task as a mere mortal? Forget it.
Robotic welding provides a consistency and a level of strength. There's the same level of capability in that weld regardless of whether it's on a Monday or a Friday.
The next build station's called the rollover. Technicians tackle the hard-to-reach welds and any high-stress areas that have to be extra strong. This work demands the human touch.
Our eyes are a lot more sound than the ones of the robot.
Each frame uses an amazing 125 kilos of welding wire, a fast-melting metal joiner that works like hot glue. Welder Shannon Bale is working on structural supports called drop tubes.
The reason why this weld has to be so tough is because it's a very high stress area. It's always under an extreme amount of stress because on each end of this tube, we have 2 cylinders that raise and lower the bed of the truck.
Shannon's using a special welding wire made of carbon steel that hardens fast to prevent drips. This speed-freezing wire allows welders to work uphill without making a mess, but it's delicate work.
I would strike an arc here, and what I do is, if you could see this, I'd hold here, then I'd come over here like a Christmas tree, then I'd hold here, then I'd come up just a little bit more, then I'd hold here for a little bit. That way we're tying these sides in together, and then just keep on working your way up. When I first got over here, this is the job I wanted to do, because this is so neat.
At last, the frame assembly's titanic task is done. All 9 pieces have been welded together. But before this build can go any further, this frame gets a tough inspection. A 797B's frame must be rock solid, or the whole truck could collapse. Technicians double-check critical seams with a tool called an ultrasonic flaw detector. It's a lot like the ultrasound used to monitor babies in the womb. Ultrasound technology works similar to sonar. The tool emits high-frequency sound waves through a special conductor gel. An attached computer detects and converts the sound waves based on how they bounce back, generating colored images that reflect strength and weld density. The system works like an in-depth detective, revealing any flaws. Justin James is in charge. He takes 3 hours checking every frame.
Like right now it's light blue, which isn't very bad. Now if you see red or yellow, then that means that we're gonna have a problem.
No red in sight. The welds are good. Next up, painting. Today, the paint booth team's working on a giant earth-raking machine called a motor grader. Every Caterpillar vehicle gets a 2 to 3 millimeter coat of durable trademark yellow. And this is no ordinary paint job. Caterpillar sticks to a method called an electrostatic paint process. A specially designed spray gun gives the paint a negative electrical charge, while a supporting track gives the tractor part a positive charge. When the yellow spray flows, the negative paint attracts to the positive steel. And voila, a flawless finish. Here on Alberta, Canada's oil sands, oil is everywhere. It's literally trapped in the sand. It takes off-site refineries to physically separate the oil from each grain. But underfoot, this oily, sandy mixture makes the ground soft, sticky, and abrasive. Tough conditions for the 797B. And even tougher conditions for the world's biggest tire. Towering over 4 meters high, weighing 5 tons, each giant XDR tire is as tall as a 1-story building and sports enough rubber to tread 500 regular-sized cars. They cost a lot too, anywhere from 35 to 65,000 euros a piece. Each 797B dump truck needs 6 tires total, 2 up front, 4 in back. That's a heavy tire payload. These supersized tires get their start thousands of miles away at the Michelin Tire Factory in South Carolina. To build these monsters takes several critical stages. First, the raw rubber goes through a machine called a plastifier, where it's ground up into gooey pellets. The pellets then travel to the mill, where another mega machine called an extruder stretches the soft pellets to create a thin rubber layer.
At the mill, the rubber is flattened so we can cut it and make it into bands where we can feed it over into our extruder.
The massive rubber sheets spray cool and dry off. Workers roll them into a circle. But to become a true tire, this rolled rubber needs painstaking personal attention. Incredibly, at the hand assembly area, workers hand form every 797B tire. As the team smooths and aligns them, the sticky rubber sheets naturally adhere to one another. It takes a lot of rubber layers, up to 130 sheets in total, to form the tire's main surface.
As I'm laying it, use my hands to make sure that it stays on that laser and that it has the right amount of tension applied. All the products are laid evenly all the way across. And roll down the joint to release any air that may be trapped.
Technicians then insert a layer of rubber-wrapped steel to give the tire strength and durability. The bigger the machine, the more steel layers these tires need. A large earth mover tire may use as many as 6 steel layers, called belts. Technicians place these huge rubber rolls into a top-secret mold. Here, pressure and heat force the rubber to take on the tread pattern that makes these Caterpillar tires the strongest in the world. 12 hours later, the finished tire emerges. But before any tire can hit the road, it has to pass inspection.
I'm looking for any kind of non-conform on the tire, blister, bad molding, foreign matter, or anything of that nature.
At last, the gargantuan tires pass the test. They're as solid as they are huge. These tough treads are now ready to stand up to the worst conditions the Alberta oil sands can dish out. And out here on the job, these mega beast vehicles have to run 24 hours a day, 365 days a year. The secret to their success? A 3,550 horsepower engine. To get to this towering dump truck's engine, you have to climb a flight of stairs. The 19-ton engine sits deep in the dump truck's belly. This helps give this giant earth excavator a low center of gravity, keeping it stable on rugged terrain. But to see the creation of this monster diesel-burning power plant, you have to travel all the way to Lafayette, Indiana, to the 140,000 square meter birthplace of the 797B's engine.
There's no greater feeling of power than building a 3500 engine.
Just how massive is it? For sheer power, it would take 7 Ferrari F430 engines to match it. And weight? At over 19 tons, the engine alone weighs more than 8 Ford F-150 pickups.
Max of what you'd see in your car, the little 8-cylinder engines. And here we have 24, and not only that, they're really big. So it's pretty awe-inspiring to be working on something that's this large.
These 24 cylinders add up to major horsepower. Horsepower measures the maximum power output of an engine. The bigger and heavier the vehicle, the more horsepower it needs. The trick to building an engine strong enough to drive this Titanic dump truck? Fusing 2 engines together into one. To craft the unique double engine, every build step here happens twice. When it's all put together, the 797B's diesel power plant turns into the largest truck engine in history.
When we needed 3,550 horsepower for this 400-ton truck, we had available to us about half that much horsepower in one 3512 engine. So what you see here is one 3512 engine, another 3512 engine. We made a mechanical connection between the two, and we made an electrical connection between the two. And what you see here is a finished product, one monster 3,550 horsepower engine. We call that a 3524.
Like most diesel engines, the fundamentals are similar, only supersized. Here's how the engine works. Inside the cylinders, pistons attached to connecting rods compress air. The pressure causes the air to heat up. Fuel then injects and combusts, forcing the pistons down and turning the crankshaft. The crankshaft transmits the energy through a set of gears that ultimately drive the wheels. The connecting rods are one of the engine's most critical components. They attach the pistons to the crankshaft. Each of these strong steel connecting rods is 3 times longer than those in a typical pickup truck. The pre-made connecting rods come to the factory in rough form. Workers machine, grind, and smooth them to a precise size and weight. Leave any rough spots, and the entire engine could break down later on.
Basically take a rough forging and you mill it, and it'll put off shavings like this, and then you'll get a surface finish like that.
When you bore the block or bore the cap and the rod, they form a perfect circle. If they get switched, it causes this circle to misalign with another part, and they no longer allow the engine to run correctly.
The engine crankshaft's next. Inside a working engine, this 500-plus kilogram giant rotates nearly 2,000 times a minute. It too must be perfectly formed and smoothed down, or it could break the engine apart. Team leader Troy Brown uses a hand-controlled hoist to lower the rough crankshaft into place. To get a perfect finish, the team uses a stone grinding wheel called a pin grinder. The pin grinder first positions the crankshaft against the stone. As it speeds up, crankshaft and stone make contact. Sparks fly, even with the liquid coolant. The grinding stops only when every surface is perfect.
Because it is an internal engine component, it has to be precise. It is the heart of the engine.
Now the engine block. This slab of metal houses all the engine's critical components. The technicians machine the sides and bottom and bore holes for wiring, fuel, and moving parts.
When the doors close, you'll see the coolant kick on, and the spindle will start turning, and we'll start generating a hole. So that's what makes this solution unique, in that we have a very accurate machine tool and that's capable of working a very large component.
Once perfectly machined, the connecting rod, crankshaft, and engine block all come together in an area called the engine assembly short line.
From this point, we'll inspect it from end to end, checking for any damage or anything that we don't want to. We'll load it up into the engine block right there behind me.
Technicians lubricate, hoist, and secure the crankshaft into the engine block. Next, the pistons meet the connecting rods. These piston powerhouses are way heavier than those in a standard pickup truck. How do you attach a piston this massive? With a piston stuffing robot.
This is connecting rod, this is the piston, okay? And then this connects to the crankshaft in the middle of the engine, and then they'll be bolted on and torqued down.
Job well done. The engine's internal parts are safely installed at last. It's time for this diesel behemoth to travel down the main line and get some personality. First, heads and rockers. During combustion, the rockers open the valves within the engine cylinders to let in air and fuel. Without rockers, an engine grinds to a halt. Workers use a mega high-tech machine called the 10 spindle to torque or tighten the bolts.
The 10 spindle is pretty cool because just one little push of the button and it's real easy.
Next, technicians install aftercoolers, fluid lines, and finally the wiring groups. At last, after multiple painstaking steps and build teams, the engine's complete. It's ready for a one-way ticket out of here and a date to meet up with one phenomenal frame. Back at Caterpillar 797B assembly headquarters in Decatur, Illinois, the engine's just arrived from Lafayette, ready to take its place inside the finished frame. Teams install the engine's hydraulics and wiring system. A crew then hooks the engine to a 55-ton remote-controlled crane. With parts this size, assembly's a big challenge. And in this case, it's also a tight squeeze.
The compartment's only so big, so it's like putting on a glove. You only have so much room.
The team carefully guides the 20-ton engine into the gap in the frame. Success. Bolts lock it firmly into place. This giant vehicle's starting to take shape. But to get this machine in the making road ready, it takes 2 skilled workers with safety straps and a remote control. They carefully guide the more than 40-ton beast onto the flatbed delivery truck.
You have to really be in tune with the guy that's beside you. Any off balance can make the straps break or you shift the truck from one end to the other. The first time you pick the truck up, you're really nervous.
Mission accomplished. The Caterpillar 797B's frame and engine are ready to hit the road. But to become a mega dump truck, there's still 2 major hurdles left: final delivery and final assembly. And it all happens almost 3,000 kilometers away in Alberta, Canada. It's gritty and grainy, and it's one of the toughest environments on Earth. The oil sands of Alberta, Canada. Here, dump truck drivers like Paula Freak spend 12 hours a day hauling ore from the pits.
Hang on.
Transporting it to oil separating and refining plants. The truck cabs their office and command center. To keep fatigue at bay, everything in the 797B cab's ergonomically designed. From panoramic view windows to hydraulic adjustable seats to control panels with user-friendly icons. Everything in here puts creature comforts up front.
We have a good HVAC system in here that keeps them cool or warm and ergonomically seated so that they don't get tired. Because if they lose control of this equipment or their attention is lax, there could be serious consequences.
To build these colossal cabs from the ground up, it all starts here. The Bergstrom factory in Joliet, Illinois. It takes a single dedicated technician about 40 man-hours to construct the entire cab from start to finish. Today, Master Assembler Brad Hill's training rookie John Chambly.
Overwhelmed, I was kind of like, is this really one person's job? Does one person really got to have this done in a certain amount?
First up, the cab seat. Getting this installation just right is critical to driver safety. The team maneuvers the seat through the door and secures it to the floor. Brad tightens the bolts by hand. Next, they attach special hoses that feed compressed air into the chamber. The air chamber hydraulically adjusts seat height. The result? Perfect driver alignment. John tries his hand installing the cab's panoramic window. Each specially designed windshield offers the widest possible sight lines of the haul road. Prime visibility that helps keep operators safe and in control. The cab's even equipped with built-in sound barriers to protect the driver's hearing over the long haul, literally. At last, after several days of painstaking build steps, this dump truck command central's ready to take its place at the helm of a monster machine. Back on the oil sands, shovel operators scoop hundreds of tons of sand into the dipper and drop them into the 797B dump truck. And to handle this mega mountain of ore, Caterpillar designers gave the 797B the ultimate dump box. Nearly 10 meters long, made from solid steel, this enormous box is so big it can hold 96 Ford Explorers. And it's assembled here at the Leo Roberts Fabrication Facility in Fort McMurray, Canada. Trained assembly teams craft about one of these monster boxes a day. The 797B box is made up of 5 prefabricated pieces: the floor, 2 side sections, the front wall, and the canopy. Welder Preston Shiner hooks up the center floor section to the crane. He joins it with the other pieces for bolting and welding and moves it to the work area. Once airborne, this 15-ton metal slab becomes a handful. The only means of control, a tag line, a piece of rope that stops the floor from swinging as it lines up with the cart. The floor must be carefully placed on the cart, or everything could dangerously tip. Crane operator Victor Major guides the first sidewall section to the cart. He carefully maneuvers it into place. To bolt the floor and sidewall pieces together, builders use a tool called an impact wrench. The impact wrench uses air compression to ratchet up the tightness of each turn. But there's a problem. Even with securing bolts in place, the sidewall and the floor won't line up. A piece of metal's in the way. The solution? Cut it out with an oxyacetylene torch. The torch mixes the oxygen with the highly flammable gas called acetylene. It creates an extremely high temperature flame, burning at over 3,000 degrees. So hot, it cuts through metal like butter. Finished. With the first side section of the 797 dump box secured, Preston maneuvers the second wall into place. The team bolts the floor and wall together. A solid fit. Now for the final piece, the front wall. The team uses a crane to grab and hoist the wall into position. But there's another glitch. The box is slanted. To line the wall up, the team has to pull the bottom in. A crew member cuts a hole in the base of the wall and attaches a winch and chain, slowly pulling the wall into place. Done. A welder now attaches bolt fixtures to the front and 2 side walls and pulls them together with an impact wrench. The last task, tack weld the front and side walls together. This stops any slippage between the 3 pieces during the final welding. At last, the behemoth 797B box is complete. But to make sure it can stand up to some of the heaviest loads in hauling, welders have one last job. Over the next 7 to 10 days, technicians fuse every joint and seam until these assembled parts can truly brave the rigors of the oil sands. Caterpillar manufactures some of the most powerful machines on Earth. But for the biggest monsters, final assembly's a giant challenge. To put the Caterpillar 797B together at any site around the world, it takes 7 technicians working round the clock, 7 days a week for 20 days. Tristan Hamilton and Soren Tomlinson work the day shift. They're assembling our dump truck in the making at the oil sands in Fort McMurray, Alberta, Canada.
Usually we work in teams. Even the tools themselves are too heavy to operate by yourself, so a lot of times it requires 2 people in order to do a job.
Mechanics have already installed the axles, the engine, and the cab group. Now it's time for one of the trickiest parts of the build, installing the 6,300 kilo transmission. This job calls for a heavy-duty crane. The challenge? Make sure the sling holding the transmission's strong enough to handle the weight without collapsing.
If we weren't to use the correct lifting devices up here, we could easily overextend the sling and break it, or we could drop something heavy and worst case scenario, hurt somebody.
To measure and monitor the sling, engineers designed an ingenious safety feature called a tattletale. The synthetic fiber tattletales, loose strands, hang down from an empty sling. As the stretched sling takes on a heavy load, the tail retracts. Technicians watch for the tattletale at all times. It tells them if the sling's stretched too far.
If this is no longer visible, then that's the indication for us that something has been done that's not right with the sling. We take it out of service.
Now the stakes get even higher. The team has to fit the transmission into a space not much larger than the part itself. One wrong move, and another part of the truck could take a damaging hit.
It's a very tight fit, and we're dealing with such heavy weights. It's very important not to let it touch anything.
The team installs the transmission with pinpoint precision. Mechanic Tom Chase's next job? Hoist the 4-meter, 5-ton tires into place. These steel-belted rubber behemoths bolt to the axle with some serious hardware.
Your typical automobile would have 5 or 6 wheel nuts torqued to approximately 75 to 100 foot-pounds. This one's got 47 nuts and they're torqued to 2,300 foot-pounds.
And a giant tire needs a giant tool. The air-operated torque wrench.
This is one of the more physical jobs that we do. Well, I try to support the machine as close as I can to my body. The farther out that you hold it, of course, the heavier it gets. So I try and cradle it in my arms and support it that way, so gotta keep it close and it's not quite so heavy that way.
With the wheels in place, it's time for rubber and ground to meet at last. The team lowers the truck off the assembly risers using 4 hydraulic jacks. Touchdown. This machine's ready to make its final journey to the mine site, nearly 25 kilometers away. But these Goliath vehicles are too heavy and too wide to travel on ordinary roads. And that calls for this beast, a whopping wheel trailer more than 40 meters long. The transport team positions the trailer under the truck. They put wooden blocks beneath the front and rear axles. These blocks support the truck's weight and keep it stable during the journey. Once the team secures the dump truck in place, the trailer slowly moves out. It's on its way. It takes 1.5 hours to travel from the workshop to the mine site. Here, the team offloads the truck. But this monster needs its last critical part. It's time to head to the workshop for the final assembly process, the box attach. Getting the dump box ready to attach to the truck is a tough challenge. Mechanic Nelson Matichuk begins by connecting strong synthetic fiber slings to the box using a 22-kilogram shackle. Before it can fit into place on the dump truck, it takes 4 slings and 2 cranes to lift the 45-ton monster box. Nelson maneuvers the first crane into position. He then connects the sling to the box.
Okay, now we'll do the other side.
Once he's got all 4 slings connected, Nelson begins the lift. He operates both cranes simultaneously to keep the box level. Surprisingly, this treacherous task has to be a one-man job.
Well, it's easier for one person to do it than 2, because if you got 2 guys running the controls, one guy will be stopping, the other guy might be starting, and you end up getting the box swinging or something. This way, one guy's controlling the whole situation.
While Nelson lifts the dump box, a driver moves our 797B out of the adjacent bay and reverses the monster vehicle beneath the dangling part. Nelson slowly begins to lower the crane. Now for the tricky part. Nelson must lower this giant swinging 45-ton box onto 2 pin supports. This is one high-pressure jigsaw puzzle.
It's not even a few inches. There's only a matter of, I don't know, there might be a ½ inch on each ear there. That's it, once the box is sitting there.
It's all a matter of timing. Nelson waits until the 2 parts are lined up and then carefully lowers the box. The box is in. Mission accomplished. The team now anchors the dump box in 3 places: at the rear pin supports, the hoist cylinders, and on 2 front pedestals. They start with the rear pin supports. The first step, jam a set of shims, 2 metal rings, between the dump box and the pin supports. This stops any side-to-side movement during operation. The next step takes muscle, hammering the pins in place.
Good job, though. Good job.
The beast's in at last. To finish the job, the team tackles the pins that connect the hydraulic hoist to the dump body. Mechanic Douglas Novice starts the 797B engine. He raises the hydraulic cylinders, lining up the pinholes with the bottom of the dump box. He's going for a tight, secure fit. The same procedure repeats on the other side of the truck and the front pedestals. Nelson positions the pin into place. Time to drive it home. Finally, Nelson flexes the monster machine's muscles, raising the truck bed. This Whopper dump truck now has the ultimate part, assembled perfectly. It's taken 6 factories, over 600 tons of material, multiple teams in about 80 days. At long last, this colossus has come together. Armed and ready to do battle on this mega mine site.
Seeing what the product does, seeing it carry 400 tons at 40 miles per hour, that gives a great deal of pride.